Okay, in this video, we will talk about unification, the concept behind the unification or matching in Prolog. Okay, so in past videos, we talked about how to define Prolog, different Prolog databases, right? Like knowledge bases, like how to define facts, rules, and other stuff, right? And how to query a Prolog system as well, right? And in my last video, we talked about how to we actually basically deep dived into the different Prolog syntaxes, right? Like atoms, variables, complex terms, right? So this is the best time now. We should understand how Prolog unification works, because that's the heart of this particular language. Okay, so if we understand how Prolog matching works, maybe later videos, it will be easier to understand. Okay, so to start with, what I'll do first is I'll give you an example. Okay, now if you remember, previously we created this particular knowledge base, right? So we created a lot of facts like parents, female, male, and then we created different kinds of rule as well, right? For the offspring, mother and grandparents, right? So let us see if I just give a query to this Prolog called female x. Okay, so if I just write something like female x over here, okay, how Prolog is answering. If you see, Prolog is one by one, it is finding all the females, right, which basically satisfying this particular clauses over here, right? So that means it will eventually find Liz, Pat, and Anne as well. So if we continue over here, okay, so Liz, Pat, and Anne over here. Okay, so how Prolog is answering this particular question over here. So there the concept behind the matching or unification lies. Okay, so now if we just talk about in very simplistic term, so what Prolog do over here, so this is an Prolog query, right, with a variable over here, right? So Prolog is basically trying to match this guy from here to this knowledge base. Okay, so if I just keep side by side over here, okay, so now how it is matching over here, it is basically placing or is basically instantiating the value of this variable x with these values and matching whether this part and the resultant clause or resultant complex term. If I just talk about, because previous video we introduced the complex term over here, right? So let us talk about in that way only. Okay, so the resultant complex term, it will match over here. So if I just if I just initialize x with Pam, so it will become female Pam, right? So it is matching with this guy over here. Okay, so that's why Prolog is answering with x equals to Pam. That means it is basically finding it out which value of x, if I just initialize with that particular value, this resultant clause or resultant complex term will be same as the complex term defined in our knowledge base. Okay, so that means it is basically matching something over here. So here is the concept of matching lies. Okay, so when Prolog finds a match, then it knows the value of that particular variable is Pam. Similarly for Liz, Pat, and Anne as well, it do the same stuff and it will give you all the answers over here. Okay, so we got fair idea like what matching is, right? So the basic idea. Now if we have to now define the matching in properly. Okay, so we will define it first informally, and then we will try to formalize or formally define the matching rules in Prolog. Okay, now if we just go back to our blackboard, okay, so if I just write it down over here informally, okay, so whatever we have discussed now, so if I just write the two terms, okay, this is called terms, which is every atom or variables or complex term, right? In Prolog we call it terms, right? We have discussed the same stuff in my previous video. I'll be giving that video link over here as well. Okay, so the two terms match if they are equal. Okay, this is very simplistic one. If they are equal, or if they contain variables, that can be instantiated, right? instantiated in such a way so that the resulting terms are equal, that the resulting terms are equal. Okay, so that is what we have seen, that for that female X query over there, or goal over there, right? So if I just give couple of examples over here. Okay, so for an example, so if I just give couple of examples over here, Pam and Pam matches, right? So if I just say Pam, this is a atom over there, right? And Pam matches because they are same atom over here, right? Because they are same atom. So if I just go back here, I'm talking about this Pam over here, the input of this particular complex term over here. Okay, so here everything is atom. We have discussed the similar stuff over there as well, right? The arguments of the complex term can be any kind of terms over there, right? It could be an atom, constant, or it could be another complex term as well, right? It could be a variable as well. Okay, so in this case it is Pam. So if Pam is a atom, right, then Pam and Pam will always match because they are referring to the same atom over there, right? Now similarly, if I just go back to our blackboard again, so similarly 42 and 42 matches because they are same number, right? They are same number over there. Okay, now if I just say X and X, they are also matches, right? Because they are same variable. So if I just initialize X with Pam, so this X will be also initialized with Pam because they are same variable, right? So that means it will be ultimately matching because they are variable, right? So variable can be instantiated with any values over there, right? So that means they match if the same variable matches as well, because they can be they will be instantiated with the same value over there, right? So if I just give some more examples, like if I just say female Pam, this is a complex term, right? And female Pam, this is also matches, right? Because they are same complex term. This is also matches because of same complex term, right? Now if I just say give another example, let's say female Pam, okay, and female let's say Liz, okay, they don't match because they are different complex term. Doesn't match because they are different complex term. Okay, so now if you see, like, we have to formally define why they are different. Okay, we will do that one because it's very easy to see over here, like because of this argument of this female functor is different, that's why we are calling it different. But we will be defining formally this complex term and for other variables and other terms as well. Okay, so now if I just give some more example here, let's say Pam, which is a atom, okay, and X, will they match? Yes, they matches as well because X can be instantiated with Pam, right? In that case X and Pam matches over there, right? So if you see, like, if we just refer this informal definition of the unification of matching or matching over there, either they are equal or they contain a variable that can be instantiated in such a way that the resulting terms are equal. Okay, so they also matches over here. Okay, so as X can be instantiated with Pam. Okay, so this can be matches as well. Now what about this one, female X, okay, and female Pam, will they match? Yes, because again this X can be instantiated with Pam over here as well, so they also matches because of the same reason as x can be instantiated with PAM over here. Okay, so now if I just give a final example here, let's say parent. Okay, there is another fact we have defined before, right? So x comma n, so this is one of the complex term, and let's say there is another complex term, let's say parent. Okay, parent Bob comma x. Now think about this one, will this two matches? Now they doesn't, because of the same reason. If I just instantiate x with Bob, okay, so in this case the first one will become parent. So let us do that one, let us do that one. So this going to be fun. So if I just, let's say, instantiate x with Bob, okay, because we are planning to match with this guy over here, because the first argument of this parent is Bob over here. So the first one will become parent Bob comma n, right? And the second one will become parent Bob, but as we have already instantiated x with Bob over here, right? So this will again become Bob, right? If you see it, after instantiation also, these two complex terms are not matching because these arguments are not same over here, right? So that means these two terms will never match. Okay, again, if you instantiate x with n over here, okay, the same thing is going to happen. So the first one will become parent n comma n, right? And the second one will become parent Bob comma n, right? So again they are not matching over here. Okay, so we got a fair idea about like how two terms matches, right? And while doing that, we actually talked about this different complex term over here as well, right? And we say they do not match even though after we initialize x with something. Okay, and we informally said because by seeing through itself, because these arguments do not match, that's why they are not matching. So it is a time we can formally define what rules or different rules which we need to follow when we talked about matching or unification in Prolog. Okay, now let us work on the formal definition of matching over here. Okay, so let me go down a bit. Okay, should be fine. Okay, formal definition, okay, or the set of rules we'll be talking about here. Okay, so the first rule is, let's say if I just write it down over here. Okay, so if term 1 and term 2, okay, so we are talking about two different terms, whether they will match or not. That's why I'm referring them as term 1 and term 2 here. Okay, are constants, okay, then term 1 and term 2 match if and only if they are same atom, right? So this is very simple rule, they are same atom. Okay, so or the same number, because the constant can be two types, right? We have seen in my previous video as well. So only they can be either atom or the number, right? Or same number. Okay, so this is the first rule over here. Okay, so we'll take a couple of examples as well. So if I just take a couple of example here. Now while doing that one, okay, I'll try to introduce a Prolog system defined functor or complex term called equals to /2. Now okay, so if I just write the /2 here, because I'm using LaTeX here, so sometimes it just auto correct itself. Okay, so anyway, like say this, if you remember from my previous video, I have said, like when we talked about any kind of complex term, we generally, when write it down, we write down its arity over there, right? How many argument it takes. So this equals to functor or equals to complex term is basically taking 2 arguments over here. That's why I'm saying 2 over here. But when we'll be using it, we will not be writing in this way. Okay, this is just this one. So this is equal, the functionality is similar to equals to, if I just write it in very simple term over here. Okay, so to match or to know whether 2 terms are matching or not, or to test 2 terms are matching or not, we can use this particular functor or operator over here. Okay, to know whether this one. So to check it out, what we can do is let's check it out with couple of examples over here. Okay, so if I just write equals to, okay, that's the name, that's the functor name, Pam comma Pam. If you see it over here, Pam is an atom over here, right? So if I just give this particular query to Prolog, it is saying true over here. Okay, similarly, if I just give equals to Pam comma Tom over here, okay, it will say false because those 2 complex term does not match, right? So that's why it is saying false over here. Now this can be written in this way, or this can be written in this way as well. If I just write Pam equals to Pam, okay, dot, then also this is also fine. So this particular functor you can use in both of these different ways as well. Okay, so we will prefer this one because we used to write with this kind of way only, right? Now if I give a query something like that one, let's say how Prolog is reacting over here. Okay, within single quote Pam equals to Pam. Okay, so if I just give this one, if you see, Prolog is saying true over here, because if you remember from my previous video, when we are defining atoms, right? So we can define atoms within this single quotes as well. So the value inside the single quote will be becoming the value of that particular atom over here. Okay, so as this both of this way we can define atom, okay, and the value of these atoms are same over here, so that's why Prolog is saying true over here. Okay, now similarly, now see what is happening over here. So if I just give this one equals to 2 over here, okay, so if you see, Prolog is saying false in this case because 2 is a number, okay, and this is an atom over here, right? The value of this atom is 2, even though, but both are different stuff over here. We are on the left hand side we have a atom, and the right hand side we have a number over here, so that's why it is not matching over here. Okay, so that's why Prolog is returning false over here. Okay, now we got a fair idea about the rule number 1, that is related to the constants. Okay, now let's talk about the variables over here. We are moving to rule number 2 over here. So let us move on. I'll just go up a bit. So if we just define the rule number 2 over here, okay, so if term 1 is a variable, okay, if term 1 is a variable of variable and term 2 is any type, okay, is any type of term, it could be atom or it could be a constant, or it could be a variable as well, okay, then term 1 and term 2 match, okay, match if term 1, which is a variable, right, if term 1 is instantiated with term 2, right? So if I can instantiate term 1, which is a variable, with term 2, which is basically any type or except variable over here, so then these two stuffs are matching, right? Similarly, if term 2 is a variable, okay, so similarly if term 2 is a variable, okay, and term 1 is any type of item, okay, any type of item, then term 1 and term 2 match, then term 1 and term 2 match, okay, if we can instantiate the term 2 with term 1, right? So that means match if term 2 can be instantiated to term 1, right? To term 1. So instantiate 2, better instead of with we should write 2 over. Okay, now if both are variable, okay, if both term 1 and term 2 are variables, so in that case they both can be instantiated to each other, right? They are both instantiated to each other. That means the same value over here, okay? So that means they share the values, okay? That means they share values, okay? So if let's say term 1 and term 2 are variables, we can initialize term 1 with PAM, which is an atom, and if we initialize term 2 with PAM again, which is similarly an atom, so in those cases term 1 and term 2 will match over there, okay? So we will take a couple of examples as well. So let's go back to our Prolog environment. So now if I just say PAM, okay, equals to X, so if you see the left hand side we have our term 1, which is an atom, and the right hand side we have a term 2, which is a variable over here, right? So that means we are dealing with roll number 2 over here, right? So if we can instantiate X with PAM, then this 2 will be matching, okay? Now that is what Prolog is also finding out over here. If you see, it is saying X equals to PAM. It is not saying true and false over here, okay? When we are dealing with a variable in a particular goal, by using that matching rule only, Prolog is basically finding out the value of that particular variable over here, okay, instead of true and false over here. That means what value of this particular variable will make this particular term match, or particular term matching equals to true over here, okay? So that is the concept behind this one. So again, if I just say now, if I just give this particular query over here, I think this based on Prolog implementation, this output will be varying some way, okay? Here it is saying X equals to Y, because even though X and Y are both variables over here, sometimes you may get true based on the Prolog system you are using, okay? Sometimes you may get a number over here, or you may get another variable which will basically tell both of these variables are assigned to that particular same variable, okay? So maybe you will get something like X equals to underscore something and Y equals to underscore the same thing over there, some variable name, okay? So just to like states the fact that like both of these two variables are actually sharing the same value when we are talking about the matching over here, okay? So now if I just give a term with AND operator, let's see how it works. If I just give X equals to PAM, okay, comma, this is the AND operator over here, right, and X equals to term. Now what do you think, like what will happen over here, okay? So if you see, now it is telling me false over here. So let us analyze this particular input over here, okay? So X equals to PAM, that means we are basically, when this particular goal will be true or match when we are initializing X equals to PAM, right? That means this particular stuff will become PAM equals to PAM. So we have already initialized X equals to PAM, right? So that means here it will be becoming X equals to Tom. So if I just go back to our blackboard, okay, so this is important to understand. So if I just, so our query is X equals to PAM, comma, X equals to Tom, right? So this was our goal over here. Now to match to, if we apply our matching rule over here, when this particular two terms will match, when we initialize x with Pam, right? So x equals to Pam, we have initialized it over here. So our first term is becoming Pam equals to Pam, right? So this is true because they are that is why we have matched it, and we have defined this particular variable as Pam over here, right? Initialize that particular variable as Pam over here. Now as we already initialized x equals to Pam, the other part of this particular goal or particular query will be becoming Pam equals to Tom, right? So which is false. So this AND operator, this is the AND operator over here, right? So this left hand side is true and the right hand side is false. So that's why ultimately it is becoming false here. Okay, so that's why Prolog is returning you false over here. Okay, now let's move on. Let me go down a bit over here to our third rule. Okay, so third rule is basically for the complex term. Okay, so if term 1 and term 2 are complex terms, okay, then they match if and only if. Okay, so there are three different rules over here. So if and only if they have the same functor and the arity, this is the first requirement. They have the same functor and arity. Okay, I have defined what is functor and arity in my previous video. Okay, so that's the first requirement. The second requirement will be, okay, now the second will be the all their corresponding corresponding arguments match. Okay, arguments match. So this is the second requirement. That means the first argument of the first term should be same as the first argument of the second term. Similarly for second argument with the second argument as well. Okay, and the third requirement should be, and the variable and the variable instantiations are compatible. We will see what do we mean by this one over here. Okay, so similar stuff over here, similar kind of concept over here. Okay, so we will see like what do I mean by variable instantiation should be compatible over here. Okay, so we will move back to our Prolog environment now, okay, to see a couple of examples related to this particular rule over here. Okay, so if I just move up a bit over here. Okay, so now if I just, let's say I have this particular functor called kill. Okay, I am saying shoot then gun. Okay, and the second argument is a variable over here for this particular complex term equals to, okay, kill. The first argument is a variable called x over here, and the second argument is stab knife. Okay, so if I just give this particular input or give this particular query to Prolog, okay, so how by using the matching rule Prolog is finding the value of x and y over here. Okay, so now if you see, if I just instantiate y with stab knife over here, okay, so that is what it did first. Okay, so then the first complex term is becoming kill, shoot, gun, then stab, knife, right? Now the second argument, the second functor is the right hand side functor is again kill. That means the function name is matching, the functor name is matching over here. Okay, and if we just instantiate x with shoot gun over here, that is what Prolog did as well over here. So this will become kill, shoot gun, and then stab knife. So by initializing this x and y values, these two are becoming same because the functor name is same. It has two arguments, right? There are two arguments over here, and the corresponding arguments are same. should gun, and if I just instantiate x with should gun, then it is also becoming same. Similarly for y as well, the same stuff, right? That means our corresponding arguments are also same, and the variable instantiation are compatible as well, right? Here we are talking about two different variables. It will be more clear when we will use the same variable. Okay, in those cases the instantiation compatibility issue will be there, and we'll see why Prolog is reacting in those way. Okay, so this is how Prolog is finding the answer of this one. Let's take another example over here. Okay, if I just say kill, and let's say SHOOT shoot gun, okay, comma, let's say stab knife. Okay, so this is the left hand side which we want to match with kill. Okay, x comma stab y over here. Okay, so this is the query we have given it now. So let's say what Prolog is finding over here. This is very simplistic, because if we just initialize x with shoot gun, okay, that is what it did, and y with knife over here, these two are becoming same in this by applying the rule number 3 over here, right? The functor name, the number of arguments, and the positional arguments, that means corresponding arguments has to be same, right? And the variable instantiation is the compatible. Now let's take this particular example now. Okay, let's say parent, we already defined this particular one in our Prolog knowledge base, right? Bob comma Pat. Okay, if this one is equals to parent x comma x, now will this two complex terms are equal? Now let us find it out. Prolog is saying false because of this same rule. So if I just take this guy over here and go back to our blackboard, okay, so if we are talking about these two guys over here, right? So now think about this one. If I just initialize x with Bob over here, okay, so what will become? The left hand portion is always fixed, it's a Bob Pat, but the right hand portion will become parent Bob comma Bob, because those are same variables over here, okay, which is definitely not matching with the left hand side, right? Because of the same rule, because the variable we cannot initialize x with Bob first, and to match the second argument we cannot initialize x with Pat over here. Okay, that is what we are talking about regarding the rule number 3 over here. Initializations has to be compatible, because we are using the same variable over here. If it would have been y, then it would be in a separate case. Okay, but if it is x over here, that means same variable which we already instantiated over here as a Bob, the second argument will also be coming Bob over here. Okay, that is what we mean by this compatibility one. Okay, so and similarly if we just initialize x with Pat over here, so it will become parent Pat comma Pat, right? Again, this will not match with this left hand part, because even the functor name is same, their corresponding arguments are not, even the number of arguments is also same, but the corresponding arguments are not matching. The second argument is matching, the first argument is not matching over here. So this rule is failing over there. Okay, so we got a fair idea about rule number 3. So the last, and I think this is the most important rule, is called rule number 4 over here. Okay, so if I just write in this way, two terms match if and only if, okay, only if it follows the previous 3 clauses that they match. Okay, so that means we are basically telling, so there are these are the exhausted rules over here. So if you cannot find a matching by applying these rules, definitely those two terms are not matching over here. Okay, so this is the most important rule over here, okay, for Prolog unification. So hopefully we got a fair idea about the unification or matching rules in Prolog. Okay, so and by design and by definition, this is the heart of the system over here. Okay, so if we understand this part, it will be easier to understand latter part as well. Okay, so see you in next video.